Okay, today what we're going to talk about is the scientific method. I'm going to teach you how to identify the control group, experimental group, the constants, the independent variable, and the dependent variable. Okay, but I'm going to do this by using an example. The first example here says, does soothing hair growth help females' hair to grow faster? Okay, so soothing hair growth is the name of the product, and we're seeing if it helps females' hair to grow faster. Now, in order to design an experiment, we need to identify these 5 things here: control group, experimental group, constants, independent variable, and dependent variable. Now, the experimental group, I've already put it here for you, but it's the test group, the group that's going to be tested. So, who are you testing? That's the experimental group. Who are you testing? So that can be, let's say 15 girls from, let's say 15 girls from, let's just call them teams, from team A, 15 girls from team B, and 15 girls from team C. Let's just say these are different teams in a school or something, and we're going to find out, we're going to take 15 girls from each of these 3 teams here, and what we'll do with these will be our experimental groups. Okay, now although we have something to experiment on, we still need something that we can compare these results to. Because if you think about it here, let's say we experiment on these girls here, but how do we really know that this worked? We have to have another group of girls that use, let's say they use no conditioner or no hair products. So that's going to be our control group. So let's say in our control group here, let's say they are not, let's put this right there, are not experimented on. Oops, give me a second here. My pen is, this control group is not experimented on. Okay. Now, this experimental, this control group here, let's say this is the other 15 girls from team A. Let's see, and so on, 15 girls, oh goodness, from team, I cannot type today, from team C, let's call it. Okay, now these girls here are going to be the girls that use no products at all. They can't have any products here. What they'll be doing is basically comparing results. So after, let's say, a time period of, let's say, 4 months. Let's say we give the hair growth product 4 months to really make sure it's in effect. So we have 4 months. For these 4 months, this control group, they will not use any hair products at all. And the only hair products that the girls in this experimental group will use will be the soothing hair growth. That's the only product, the product that we're trying to test. That's the only product they can use for these 4 months. They can't use any other conditioner, any other shampoo, anything else. Only this one hair product. And then once we see how these girls from the experimental group, the test group, how they look after 4 months, how their hair looks after 4 months, we'll compare that to these different 15 girls that had nothing done to them, and we'll compare the lengths of their hair. But now we have to do a couple of other things, because I know you guys are saying, well, what if one had longer hair? What if one hair naturally grows faster? Well, we're going to specify, and how can I say this? We're going to make sure that we have the correct, let's just go ahead and say the name now, constants. Constants are things, I know you've heard this in your math class, but constants are things, they stay the same. Okay? So, what things must stay the same in order to make sure that my results come out correct and they aren't skewed or incorrect? What must stay the same? Well, the first thing is we must make sure, so from the start, the hair length of all girls must be the same. Okay? So the hair length of all of the girls must be the same. So we have 90 girls here that we're experimenting on. So all 90 girls, their hair length must be the same. So this is including the girls from the experimental group and the control group. They must all be the same. Okay. Now, other things that must stay the same. Let's say their food that they eat, because food can affect hair growth. So food that they eat must stay the same. And also, when I'm saying food, I mean everything that falls up under that. Vitamins. Oh, not the vitamins. We'll include vitamins in their own category. Well, we'll go ahead and put it here. So vitamins. What else must stay the same? Dealing with food. We'll just leave vitamins, food and different vitamins. They must stay the same because that can also skew the information given, skew our results at the end of this experiment. So we want to make sure that stays the same. Other things that you can think of that may skew the results. When I say skew, I mean give us false results at the end that can help your hair growth. So all of that, everything must stay the same between the control group and the experimental group. I hope I'm not confusing you guys here. But what I'm saying is that the only thing that should be different, so the only thing that should be different is the hair product. The only thing that should be different is the hair product. And that hair product I'm talking about is the, of course, is the soothing, here it is down here, is a soothing hair growth. That's the only thing that should be different from the experimental group and the control group. Everything else needs to stay the same. Okay? Now, our independent variable. Well, what is this? What is this independent variable here? We also call this the manipulative variable, the manipulated variable, the variable that I'm going to manipulate. I'm going to change it. So the independent variable is what is different from the experimental group, we'll call that EG, and the control group, which we'll call CG. What is different between the experimental group and the control group? And in this case, the independent variable would be the hair. What is it? The soothing hair product or hair growth. That's the only thing that should be different, which is what I changed, and it's the soothing hair growth here. Okay, that's my independent variable. It's my manipulated variable. What did I take from this experiment? What did I manipulate to in order to do test on, which was the soothing hair growth? Now, my dependent variable. Let's talk about this for a second here. My dependent variable is also called my response variable. How does this respond? How does this respond? What responds to the independent variable? Now, you know in math how you have your x and y. How you have your x and y, and we say that y depends on what x is, and we have a function or anything like that. So in this case, it's the same thing. Our dependent variable is going to depend on what our independent variable is. So if our soothing hair growth actually works, then our dependent variable or our response variable would mean longer hair. correct? Or something like, that's basically going to be our response variable. That's going to tell us exactly, is this independent variable, this soothing hair growth, does it actually work? Our dependent variable is going to tell us if it works or not. It's our response variable. So it's longer hair. Or, you know, if we have longer hair compared to the control group, that's what this that's what this dependent variable is gonna tell. So let's just say length of hair, the length of the hair. Oops, the length of the hair. That's what's gonna tell us if this product really works here. Okay, so the length of hair, that will be our dependent variable, as I stated many times before. Okay, now here you have is your designed experiment. So we've identified the control group, which is the group that has not been experimented on. We have the experimental group, which is your test group. We have the constants, the things that stay the same, because we can't say that, okay, using the soothing hair product, your hair does grow faster if the people that were using the soothing hair product were also using many different hair products at the same time. Let's say they were using Suave hair product, or I don't know, a Gras hair product, just to throw out a name there, a Bamboo hair product. Let's just say that they were using all these hair products simultaneously. Then how do we actually know that soothing hair growth was the hair product that helped this hair grow? So you see how our results would come out skewed if we didn't have our constants there. That's why everything needs to be the same. The food, the different hair, nobody needs to use any other hair product. Their daily routine, what they do, every single thing that can skew these results needs to be the same to make sure we get the most accurate results. Now, some people, they do experiments and they don't get accurate results because they do not have constants, things that stay the same. But if you want the most accurate results, you need to have your constants. Okay? Now, that was one example, and then we'll do this next example here on our next video.